Hello, can everybody hear me? Okay, I'm gonna warn you guys right now in case it happens. My son is trying to find somewhere and he got lost. So if he calls, I might have to mute for just a second to help him out, but then I'll be back. Okay, so he was supposed to be there by now, but as I mentioned, he got lost. So we are gonna pick up and do one more problem out of 8-2 today. Does anybody have any questions though before we do that? Very good. Okay, did you guys try to do the homework at all? How did it go? Was it okay?
Yeah, it went well.
It went well? It was okay? Okay, good. And like I mentioned, there's really not that much different what we're going to do in 8.3 and 8.4, other than you have to recognize whether it's the z, the mean with the z, or the mean with the t, or the proportion. Once you recognize that, the process is pretty much the same. It's just you have to use it, you know, for the t, you have to use the chart a little different, and for the p, you have to use a different formula. So anyway, let's get going without further ado. This is actually the last day that we'll cover new material. Next week, we'll be reviewing for the 7-8 test, and then the week after that, we'll be reviewing for the final. So, and like I said, I really hope to have a review up for you guys. But I have a mini master class starting on Monday, which was, of course, was not supposed to overlap with these classes, but that makes things a little crazy that I have another class on top of the ones I already have starting next week. Okay, so enough of my problems. I'm sure you have enough of your own. Okay, there we go. All right, so this is another problem out of 8.2, and what I'm going to do is I'm going to leave this here for just a minute, and I'd like you to go ahead and see if you can get started on it, whether you get all the way through it, whether you just get the first part done. But let's put the steps. There's the first step is the null hypothesis and the alternative hypothesis. The second step is find your critical region or regions. And then third step is test. And then fourth step is your test value, find your test value. And then step 4 is decision. In other words, are you going to reject or not reject the null hypothesis? And are you in or not in the critical region? And then that means there is or is not enough evidence. So I'm going to leave that at that, give you a second to work on that, and before I talk. Okay, I know you're not all the way done, but let's go ahead and see if what you have done is correct. We'll get going on it together. So in this one, we're talking about rehab at different hospitals. And some of the key things, the average cost of rehab is $24,672. And then to see if the average cost is different at a particular hospital, sample of 35 stroke victims, and finds that the average cost is $26,343. Standard deviation of the population is 3,251, alpha 0.01. And that's all the numbers that we need. So out of that, what is our null hypothesis?
24,672.
Yep, and that's the mean, right?
Yep.
So we write mean is 24,672. Okay, and then the alternative hypothesis is
The different. So is it equal sign with a slash between it?
Yep, and that's just not equals.
Yeah.
So the mean is not equal to, and remember this is always the same number. So these two numbers should always be the same. Are you guys okay with where that comes from? The reason it's not your choices here are greater than, less than, or this not equal. And the reason this is a not equal is because it says different. It doesn't say higher, it doesn't say lower, it just says different. So this researcher doesn't have a feel for whether it's higher or lower. They're just wondering if this hospital is different.
I actually have a question about that.
Uh-huh.
On the homework, I had a hard time sometimes figuring out if it's too, what's it called, tied or too
tails.
Tailed.
Mm-hmm.
And I noticed that every time it was different, it was always two-tailed. Is that the case?
Yes. So so a less than and a greater than is always going to be one tail.
Okay, that's why.
What they mean by tail is like which direction you're going. So yeah. Less than means you're only going left, and greater than means you're only going right, and then not equals means you're going both directions.
Okay, I just wasn't sure if it was always. But
always. Yep,
okay.
That's exactly where it comes from. So one tail is always the greater than, less than, and the two tails is always not equal. Because this means we're only going left, this means we're only going right, but this means it could be either direction. So two directions, two tails, like towards the left tail of the normal curve and the right tail of the normal curve. So, okay, perfect. So we're gonna find our critical region. How many critical regions are there going to be?
Two.
I mean, that's exactly what, Leo was just asking, is that what makes this two-tailed? Well, it's because it's a not equals. So there'll be a tail here and a tail here. So we could end up in the cave, either too low or too high, depending on what you get out of your sample. Okay. And alpha is 0.01 and it's two tail. So go to your chart.
Yeah, I don't have it right here, so.
Yep, I'm going to pull it up. So down here. Okay, here we go. So it is two tail 0.01, and we're still doing a z-test because we're still being given the population standard deviation. So we're going to go all the way to the bottom. What's that? So it's this number. You guys good with that? 2.58? Okay. Let me know if you're not okay with that. Okay, so that would be 2.58. And then on the other side, we would have negative 2.58. So these are always matching in a two-tail. Well, for a z-test. There's another test, again, this is the one that we cut out. It's called the chi-squared test, where the left and right aren't just opposites of each other, but that's the one that we're leaving out. So, okay, so for critical region, we are going to be in the critical region if we're below negative 2.58 or we're above positive 2.58. So now let's go to the rest of the info, which says that this is what we got for our average, and this is the population standard deviation. So our test value is going to be X bar minus mu over sigma over square root of n. Again, don't have to memorize it. That's on the card. And even though it was back in chapter 6, they have it again in chapter 8. So let me pull that up really quick and just show you. So when you're doing these, you know you're doing hypothesis testing, so you know you're in chapter 8 stuff. And see here, it has that again in chapter 8. So even though it was in another chapter, they put it again in chapter 8. So, all right. And so what's your X bar?
It's going to be 26,343.
You got it. So that's what you actually got from your sample, because X bar is the population, or the sample mean. And then we're going to use the same mean we had up here. And we said the mean for the population was 24,000. It hasn't changed. 24,672. These numbers are kind of big, which is kind of a pain. Sigma is 3,251.
Mm-hmm.
Square root of
35.
35. And so this is what we have to calculate. The numbers again are kind of big.
I have it. It's 3.04.
3.04.
Yep.
Okay. And let me just pull this up really quick. If it will, it might not. Or not. All right, we'll just go with what you said. 3 point what?
04.
04. Was anybody not getting that? Everybody's got that okay? Nobody's having problems with the calculator? Okay. We've done that one enough that hopefully you've kind of got your system down on it. Now, what we're saying by that, what that 3.04 means, is that we are at 3 standard deviations above average for the likelihood of that sample being that far off from what the population mean was. In other words, what just happened is very unlikely. This is a 3 standard deviations. Remember, 3 standard deviations is really high. So we're saying that 99.7% of the samples that we get should be within 3 standard deviations, and we're above 3 standard deviations. So we're up in the area that's like really unusual. So in practice, what that means is we're going to compare it. So where's 3.04?
It's going to be above the 2.58, the positive.
Yeah, by a decent amount, right?
Mm-hmm.
It's not even super close. I mean, when we're only going from 0 to 0 to 3, that's a decent amount up. It's almost half of a standard deviation. So we're definitely up here in the critical region. So that means we're going to reject. So if we're in the critical region, we're going to reject because we're in the critical region. So we're going to reject the null hypothesis because we're in the critical region. And so there is or is not enough evidence to support the claim.
There is.
There is enough evidence. Remember, the claim on all the problems you're going to have, the claim is the second one. When they do it backwards, it reverses this is or is not. Again, it's just not good practice, so we aren't going to see those. But there is enough evidence to support the claim that the average is not 24,672. Now, we can't say that there's enough evidence to support that it's higher. Remember, we were testing whether it was different. So we can't prove, or we can't at the end say that it's higher. We have to say it's different. So even though we did find that it was higher, we can't say higher. We have to say different, because that's what we started with. If you want to test higher, so now this researcher may say, okay, well, that was pretty high up there. Let me check and see if it's higher, but they shouldn't use the same sample. They should start over again. You're supposed to make your decision about what you want your hypothesis statement and all that to be beforehand. Again, think of it like a trial. You can't go to trial and say, I'm going to charge you with theft, and then when the trial goes your way, say, oh, I'm going to add another charge. I'm going to, do theft and threatening with a firearm or something like that. You can't add a charge onto it just because the first charge went well. So you have to start over. If you want to add another charge, you'd have to start over and do a whole new trial. The other thing you can think of, it depends on, what your background is. This might be more helpful. Think of it like a science experiment. When you do your science experiment, you can't do a hypothesis at the beginning of your science experiment, then do your experiment and find something out and then go, oh, I really wish my hypothesis had been this. You can't do that. You can't change it after you have your results. So think of this like a trial or a science experiment. You make your decision at the beginning, and then you get your evidence. So we have enough evidence to support that this claim was true. So the poor little null hypothesis got convicted. Does anybody have any questions on this?
What does the A equals 0.01? What is that really telling me again? That's how accurate it's going to be?
Yep, that's the probability of a type 1 error. And that type 1 error is when you convict the null hypothesis when it was actually innocent. So when you reject when the null hypothesis was actually true.
Okay.
So this has a pretty high alpha level, and we still rejected. So you can be pretty confident that this is the case, that other hospital has a different average cost of rehab.
Okay.
Because we had a pretty small alpha level, pretty small level of probability of error. And we had a number that was pretty high above, even at that, it was pretty high above our critical values, or our critical value on the right. And so this was pretty strong evidence that hospital has a different
and the critical
average
value
cost.
is saying where it has to be, right? If it's below, it means it's not true, or it's
right. So if we had ended up anywhere, so if we had ended up anywhere in here, we would have not reject.
Okay. Yeah, sometimes I just have a hard time understanding what it means, even if I know how to do it.
Yeah, so the reject means that it had such a high standard deviation that it's very unlikely that it occurred just by sample variance.
Okay.
So what we're saying is this is not just due to sample variance. This hospital actually has a different average cost than what's normal.
Okay.
So that's what we've, yeah.
Okay.
So that when we reject the null hypothesis, we're basically supporting the claim. So we're supporting that the average is not 4,672 at this hospital.
Okay.
Yeah, and that's great, because I mean, I want you guys to understand it, because it helps you to not make silly errors or little errors. And also, if you're ever going to use this in the future, or when you're reading articles, you guys might end up being in charge of some sort of a medical facility or department at a hospital or something like that. I know a lot of people in statistics are in medical fields, or you might go into business, or you might just use it for your own sake. But if you're reading something about some research that's done, it's a whole lot more useful if you know what the words in the article mean. So even if you don't end up being a researcher yourself or a statistician yourself, which most of you aren't going to be, but you should have a basic knowledge when you get done with this class, when you're reading an article. Oh, standard deviation, I know what the heck that means. Oh, it's statistically significant. We haven't used that word very much, but statistically significant is this. So when we reject the null hypothesis, this is a statistically significant difference. So we're saying that's that difference of between 26,343 and 24,672, we're saying that's statistically significant, that's different enough that we think it's actually different. So that's the word that you'll read in the document. There was a statistically significant difference between this and that. And that's what that means. It means it failed the hypothesis test. So, okay. So let's go on to, I think we're going to leave 8.2 now and go on to 8.3. There are some other examples in 8.2, and we can come back and do them if we want. But the reason that they do more examples isn't, I don't think necessarily that we need more examples, but they go and show the p-test. But we're not going to do the p-test, the p-value test. So the p-test, that sounds horrible. It sounds like we're doing a drug test. So we're not going to do the p-value test because we're going to stick with just the traditional. So let me pull this up because this is exactly what we were just talking about. So you should have a slide that says this, even though we're going to skip those examples. Let's pop this up. So this is what we were just saying, that the researcher should distinguish between statistical significance and practical significance. So when the null hypothesis is rejected, like we did in this problem, it cannot be concluded that the difference is, it can be concluded that the difference is probably not due to chance and thus statistically significant. However, the results may not have any practical significance. So it's up to the researcher to use common sense to interpret it. So they're just saying, just because it's statistically significant, then they have to kind of look at it and say, well, but is it practically different or practically significant? But you got to do that statistical significance first. So let's look at 8.3. Okay, before we do 8.3, I won't go back and talk about chapter 7, but remember chapter 7 is the same. 8.1 was just intro. So this is all about hypothesis testing. So 8.1 was just an intro. And then in 8.2, what we just got done with, we were doing means with the sigma, and we were doing a z-test for that every time, right? Always just going all the way to the bottom of the chart and getting that value. So what are we going to do in 8.3?
The t-test?
Yep. And that means we're going to be given means with only the S. There won't be a, it won't say population standard deviation. It'll say they did a sample and found in the sample that the average was this and the standard deviation was this. That's from the sample. So, yep, we have to do a t-test, which means we have to do degrees of freedom.
And the S is the standard deviation for the sample versus the population.
Yep. So
Okay.
sigma is population standard deviation, and then S is sample standard deviation. Okay. And then in 8.4, we're going to get back to, or we're going to do proportions. And proportions, we're back to the z-test. It's a different formula, but it's the same thing. So 8.2 is kind of like our basis. That's like kind of where we started. 8.3, what changes, we use the same formula basically, but we got to use the degrees of freedom on the chart. And then 8.4 has a different formula, but it uses the same chart. So this one uses a different formula, or this one uses a different place on the chart. This one uses a different formula. So 8.2 is kind of our starting point. Okay, so let's put up the formula for a t-test. And I said the formula is pretty much the same. It is different in reality, but in practice, it's not much different. So instead of a Z here, they have a T. And instead of a sigma here, they have an S. So our formula is T equals X bar minus mu over S over square root of N. And we have to use the degrees of freedom, which is one less than the population size. Or not population size, sample size. Okay, but everything else is the same. We're going to do the same 5 steps. So let's look at our first example here. I think this first example, we're not actually going to do a hypothesis test. We're going to just look at the chart. So it says, I'll put a bunch of them up here. I'm going to clear this up too. You guys don't need this. We're okay to clear it? We're good? Okay. Okay, so here's the first one. It says go to the chart and find the critical t-value if alpha is 0.05 and the degrees of freedom is 16. I'm going to put all three of these up here. There's like 3 of these. And I'll pull the chart up here in a second if you don't have it. So now we want a t-value for alpha 0.01, degrees of freedom 22. And then last but not least, we want a critical value alpha 0.10 with degrees of freedom 18. So we're just going to practice on the chart here for a second. So this first one, it says alpha is 0.05. And it gives us that degrees of freedom is 16, but they're never going to give you the degrees of freedom. They're just going to give you the sample size. So if degrees of freedom is 16, what was the sample size?
17.
17, yep. So in the problem, you're going to get the sample size is 17, and then you have to know that that means the degrees of freedom is 16. And if it's a right-tailed test, what was the null hypothesis? If it was right-tailed.
Is it 7? Wait. Oh, it's
I'm just looking for, was it less than, greater than, or not equal to?
greater than.
Greater, yep. So they don't tell us that in the problem, but in this problem, but in the original problem, if we were looking up an alpha 0.05, degrees of freedom 16 right-tailed test, that means our sample size must have been 17, and we must have had a greater than in our alternative hypothesis. So let's go look that up. So alpha 0.05, right-tailed, degrees of freedom 16. Okay, so alpha 0.05, right-tailed. Okay, so right-tailed means we're going to look at one tail. Alpha 0.05 means I'm going to look at this column. You guys can see my cursor, right? Like when I move that cursor around, you guys can see it, right?
Yes.
Okay, good. All right, so we're going to go to 0.05, and then we're going to go to degrees of freedom 16. So that's this number right here, 1.746. The chart gives 1.746. I don't know if your homework will say to go to 2 decimals or 3 decimals. So 1.746, 1.75, depending on where it tells you to round it. There was something I was going to say. Oh, when I do a hypothesis test, like when I give you guys a hypothesis test, it will never be close enough that if you round it to 2 decimals instead of 3 decimals, you're going to be wrong. I mean, if I give something that's a reject, it's going to be like, 2.1. It's not going to be 1.748. I'm not going to give you anything that's that close in making your decision. So don't worry about, just do whatever Connect Math does, and on your homework, when you're doing it on the test or whatnot, just whatever you want. I would just do 1.75 or just write down I guess it doesn't really matter, whatever you think is easiest. So 1.746 or 1.75, either one would be fine. Do I need the negative on it?
Yes.
Oh, wait. Right. Oh, wait. It's a right hand, right?
It's a right-tailed, good. So do I need the negative?
No.
Nope, it'd be right there. Okay, so let's do this again. So we've got alpha 0.01, and then degrees of freedom 22, which means our sample must have been
23.
23. And it's a left-tailed test. I'll put that over here. So it's a left-tailed test, which means our alternative hypothesis must have been a mean that was
Less than
the null hypothesis. Okay, so when we go, we're looking for a left-tailed t-value on the chart. Okay, alpha 0.01, degrees of freedom 22, left-tailed. Alpha 0.01. I'm looking at one-tailed because it's left-tailed. 0.01 is clear over here. And then degrees of freedom, oh, I might have to go down just a little bit more than I am. Should be right here. You guys okay?
Yes, ma'am.
All righty.
And
So,
it would be negative, right?
yep. So negative 2.508. You got it. Because it's on the left side. Ooh, that did not come out very well. It does not look like a 5. Okay, so negative 2.508. So in this case, if we were less than negative 2.508, we'd reject. In this one, if we were higher than 1.75, we'd reject. Okay, so now we've got a two-tailed. Degrees of freedom is 18, which means our sample size in the original problem would have been 19. Degrees of freedom, 18, alpha 0.10. And then the two tails means
Both
that
negative and positive.
yep, we're going to have a tail here, or a rejection area on both ends. And in the original problem, the alternative hypothesis must have been a mean that was
Not equal.
not equal to whatever the null hypothesis had. Okay, so two-tailed alpha 0.1 and 9, or degrees of freedom 18. Two-tailed alpha 0.1, degrees of freedom 18. So right here. Just make sure you look at the two-tailed row before you go over to your column. So 1.734. And of course then negative 1.734. So in this case, if when we were doing the test, if we came out with our test value below negative 1.734 or above 1.734, we'd reject. If it was anything in between, you know, from 0 down to before you get to negative 1.734, or from 0 up to before you get to 1.734, any of those values we'd not reject. They do a lot more, in the examples, they do a lot more reject than they do not reject, which I don't like because it makes you feel like it's almost always going to be a reject, and that's not really true. Okay, so let's clear this up and actually do one. And I always tell students, if you get stuck on it, keep going, because if you don't pick anything, of course it's going to be wrong. So just go with what you think it is and then finish up the problem. I still have not decided how to do the hypothesis testing on the test. I'm trying to decide whether to like give you examples of what like a student might have had and make you pick which one's right. But what I want to do is I want to be able to give you credit for if you make a small mistake in the first step. I don't want to then dock you everything after that. So I don't want to, oh, you just made the mistake of you're doing a Z instead of a T, and so that gets you a different value, and then you miss everything after that. I don't really want that to happen. The other thing I might do is I might have you send in, like I might have you write it down and send it in. I don't know. I haven't decided yet. I'll figure something out. Okay, so our steps are, step 1, write our hypothesis statement. Step 2, we're going to do our critical region. Step 3, we're going to find our test value or our Z. And step 4, we're going to do our decision. And step 5, we're going to do our conclusion.
Wait, was it a T or a Z?
Oh, thank you. What is it, guys?
Well, I thought it was a T.
It is a T. Because we're in 8.3, it's a T. But also, we'll point out in the problem while it's a T also. Okay, so a medical investigation claims that the average number of infections per week at a hospital is 16.3. So this is our original, like, status quo number. That's going to be our null hypothesis. A random sample of 10 weeks had a mean number of 17.7 infections. The sample standard deviation is 1.8. Is there enough evidence to reject the investigator's claim? So what do you guys think this should be? Should this be a less than, a greater than, or a not equals?
Is it not equal?
Does it ever say greater than or less than?
No, ma'am.
Nope. So you are
Yeah.
correct. It's a not equals. So that's perfect. Okay. So, and again, that has to be the 16.3. We don't want to throw in that 17.7 yet. We don't use that till we get down here. So his claim is that it's not 16.3. This is worded kind of weird. I like to word it really direct. Like I will say in a prior study, this, and the sample or the, population standard deviation was this. Like I like to just kind of give it in the order that it is. You'll see when you do, there's some reviews in D2L that I wrote for hypothesis testing, and the way I word them in those is how I'm going to word them on the test. I'm going to try to be really straightforward. You shouldn't have to hunt for stuff. Sometimes in the homework they word it out of order and stuff, and you have to hunt for stuff. Okay, a random sample of 10 weeks had a mean number of 17.7. Sample standard deviation is 1.8. Is there enough evidence? So how do we know from looking at this if this is a Z or a T?
Is
The
it giving
standard
an example?
deviation- Oh,
Perfect.
wait.
No, go ahead.
Yeah.
That's fine. So you guys are both saying the same thing, that it's because they say sample standard deviation, right?
Mhm.
Yeah.
And so since if we only have the S, we do a T, right?
Yep.
So this is a T. We still need to find our critical values. It's a not equal, so we're going to have both ends. Alpha is 0.05. It's two-tailed. And what else do we need when we're doing a t-test?
The DF. Oh, I forgot
Yep.
what it stands for.
Degrees of freedom. You got it.
Yeah.
DF, which is what in this case?
9.
9. Because the sample was 10, so the degrees of freedom is 9. So it's 10 minus 1. So we have to look up alpha 0.05, two-tailed, degrees of freedom 9. 0.05, two-tailed. Okay, so here's two-tailed 0.05, degrees of freedom 9. There's our number. It's pretty high, and that's because the sample's so small. So they're saying if we're going to reject this, it better be a pretty strong rejection because we didn't have a very big sample to go off of. And we only had the population standard deviation, which makes it weaker too. Okay, so, oh geez, what was it?
2.262.
2.262. 2.262. Okay, awesome. So we have negative 2.262 or 2.262. And now we have to do the test value. All right, so X bar is the 17.7.
Yeah.
S is 1.8. And we already said N is 10. Be really careful when you do this that you don't accidentally put the 9 in. It's easy to do. Make sure you put the actual N, not the degrees of freedom. So this should be 1.4 over whatever you get for an answer for that.
I got 2.46 if I round.
Is that what other people got? 2.46? Everybody else got that? Let me know if not. Otherwise, I'm going to go with it. So 2.46, where would that be? Would that be in the lower critical region, the upper critical region, or between them?
Upper,
Upper. It'd
and
be,
it would be past the
yep.
critical.
So it's up here somewhere, right? It's past 2.246 or 2.262. So 2.46 is up in here. So we're going to
Reject?
reject the null hypothesis because we are in the
Yes, we
critical
are.
region. And so for conclusion there, remember these are going to be fill in the blanks. So reject, in, and then here it'll be so there is or is not enough evidence.
There is.
There is.
Yes,
It's
there is.
always all positives or all negatives. So if we do not reject, it's because we're not in the critical region and there is not enough evidence to support. Perfect. See, it's the exact same thing, except we have to recognize that it's a T and do degrees of freedom. But everything else is exactly the same. Okay. And this one, they actually give the raw data. So I'll just fill in what the average and the standard deviation are because we're not going to calculate those. Oh, I got to clear this up first. I wish I could keep this and just get rid of the picture, not have to rewrite that every time. Okay. So this is our next one. And of course, because it's 8.3, we're probably can assume it's going to be a Z, but let's try to pick out Y, or a T. We'll have to pick out why is it a T. So according to payscale.com, average starting salary for a nurse practitioner is $79,500. A researcher wishes to test the claim that the starting salary is less than $79,500. Random sample of 8 starting nurse practitioners is selected. Is there enough evidence to support the researcher's claim at 0.1? And like I said, I'm going to cheat and just get the average off of here. Find it. So the average from the sample, the sample average is 75,150, and the sample standard deviation is 6,937. Oops, hold on, I wrote that down wrong. It's actually 938. Okay. So step 1, hypothesis statements. You go ahead and write what you think those are. Because if you know you can start it, then it makes it a lot less daunting to get going. All right, so what did you guys have for the null hypothesis?
M equals 79,500.
You got it, 79,500. And then what'd you have for the alternative hypothesis?
Is it not equal to?
Nope, not in this
Oh.
case.
Less than,
Less
right?
than.
Less than. Right here, you got to watch for this. A researcher wishes to test the claim that the starting salary is less than.
Oh, I was looking at enough. Oopsie.
So you want to look for, the keywords less than, not, lower than, under, things like that. Anything, if it indicates a direction, you have to do that direction. So this one does indicate we're looking to see if it's lower. So we do that. And then for step 2, we want to find our critical region. And so we're going to look for a critical region down here because it's only less than. And what else do we need to know?
Don't we need to know the sample mean?
We do. It's right here, 75,150. Well, we need that for 3. We don't need it here yet.
Oh, okay, I see it.
Yeah, this will be given.
Need the alpha.
We need alpha. Okay, so alpha is 0.10.
Mhm.
What else do we need to know?
We need the DF, which is 8 minus 1, 7.
Yep, so DF is 8 or 7
Yeah.
because the sample was 8.
Yeah.
Okay, and then we also need to know that it's left-tailed. So when we look it up on the chart, that's one-tailed, and we'll have to negate it. Okay, so alpha 0.1, left-tailed, degrees of freedom 7. 1. One-tailed 0.1, right? Yeah, 0.1 degrees of freedom 7. So this number right here. Is that right?
1.4. Yeah.
Alpha 0.1, degrees of freedom 7, one-tailed. Okay, so 1.415.
Yes, ma'am. That's what I got.
Yeah, and then it'll be a negative, right? Negative 1.415. So this is actually a pretty, it's not down that far, so it's more likely that we're going to end up rejecting. We'll see. Because anything less than negative 1.415 is going to reject. Okay, and then that, how do we know it's a t-test? Like, how did we know we were supposed to do degrees of freedom here and do a t-test?
You need for the sample.
It only gave us the sample, right? So if we do the mean, mean with Z, if they give us sigma, and we do the mean with T, if we only have S. So in this case, we only had S. That's why we're doing degrees of freedom. So we're actually finding a T here. X bar minus mu over S over square root of N. So what's X bar? Where's it at? I'm missing it. Oh, it's right here. I wrote it myself. Okay, 75,150 minus the mu of 79,500.
Quiet, please.
And then the S is 6,938 over square root of,
8.
yep, square root of 8.
And I got the answer if you want.
Okay, everybody go ahead and do it real quick, and then we'll compare. What'd you get, Leo?
Negative 1.77.
Like I said, they kind of overdo the reject on these. You will have ones, in your homework and on the test that are not reject. But this one ends up being up here again, right? Or down here, rather. So it's down here. Negative 1.77 is lower than negative 1.415. So it's down in here. So we're going to reject because we're
No evidence. Not enough evidence.
but we're rejecting because we're
In the critical
in the
this-
critical
yeah.
region. So there actually is enough evidence. Remember, all positives. So if we do a do reject, that means we're in the critical region and there is enough evidence to support the claim that the average starting salary is less than 79,500. So we basically, again, remember, is enough evidence means we have convicted the null hypothesis. We are rejecting the null hypothesis. We said you are found guilty, and we're doing that because there's enough evidence to support that. So we're rejecting this, which means that we have enough evidence.
On my notes, I'm sure I got that wrong. I think the 1.77, but on my notes it said 0.773 negative. Since falls in the critical region.
Oh, I don't know what
Typing.
happened on the notes. On my notes, it says negative 1.773.
And it does below in the drawing. It just must have thought, yeah, it must just be a miss
Typo.
typo.
Yeah, I wonder why it's wrong in you guys's, but it's not wrong in mine though, because mine says negative 1.773. You guys's, my Iowa's coming out. Sorry. We don't say y'all up in Iowa. We say you guys's. Doesn't that sound stupid? Okay. So negative 1.7. Yeah, this is right. I don't know where that other number came from. Oh, I see it. It is on my. In step 4, make the decision since negative 0.773. It should be negative 1.773. All right. Are you guys good? Let me reiterate this really quick because there was a little question on this. Once you make that first decision on your whether you reject or not reject, after that you don't really have any more choices. Once you reject, you're going to reject because you're in the critical region, and so there is enough evidence to support. If you do not reject, that's because you are not in the critical region and there is not enough evidence. So it's either all positives or all nots. Does that make sense? These won't ever get mixed up. Once you have a reject, that's because you're in and there is. And once you don't reject, that's because you're not in and there's not enough. Okay, so let's look at the next one. I don't know if you guys heard, and if you're interested in such, but the Blue Angels are supposed to be flying over town between 12:30 and 1 today. They come down. They're going to come down. They'll fly right over. They're coming down from like the Conroe area. They're going to come down I-45, and then they're going to scoot over kind of by the Hardy and go up 99 to Porter, and then they're going to turn and go downtown. So I would say that, the Blue Angels, that probably takes them all of 5 minutes. So they should be going by Kingwood at like Porter and Kingwood at like, they're supposed to start at 12:30. So, 12:35. So they're going to practically fly over my house. I live off of 45. I live up by the Woodlands, but on the other side I live on the east side of I-45. So it's going to be, we're all stuck at home, or a lot of us are stuck at home, and something to look forward to. Okay. So this is our next example. Oh, I got the whole thing. I should have just done part of it. Hold on. Get that off of there. Just do the top part without any of the answer. Okay. So joggers oxygen uptake. What oxygen uptake is like how much oxygen you take into your lungs. That's what that means. So a physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. So, seems like a reasonable claim to say. He's saying that if you jog, you build up your lungs and you have a higher oxygen volume. So he's going to test that. A sample of 15 joggers has a mean of 40.6 and a standard deviation of 6. The average of all adults is 36.7. Is there enough evidence to support the physician's claim alpha 0.05? So if you're looking at this on a test and you don't know, oh, this is from section 8.3, so it has to be a t-test. If you were just taking this on the exam and you needed to decide, is this a Z or a T, and why?
It's given the sample. Wait, this one gives us the standard deviation though, right?
But read the beginning of the sentence that's in.
Oh, okay, so it's a T.
Yep. So it says A sample of 15 joggers has a mean of 40.6 and a standard deviation of 6. So it's the sample standard deviation. So which one are we going to do?
T.
T-test. And again, you know, when you're doing your homework, it's going to be pretty obvious. I would go and do, so, like I said, there's a review in D2L that's like a hard copy review that I made. There's also in Connect Math, I put up like a couple extra assignment thingies, quizzes that you can use, and I've got them mixed up. So you have to recognize which one it is. So, you know, try those and see if you can recognize which one is which. All right, null hypothesis, alternative hypothesis. So what's the null hypothesis?
Equals 46, 40.6, right? Or no?
Is that the,
Oh no.
I think it's 36.7. Is that right?
yep, and that's what I mean by sometimes they give it backwards. This is silly. I mean, you would know this part before you even started your study. So why do they put it at the end of the problem? It's to try to trick you. I won't do that on the test. On the test, I will give you that at the beginning. I will say a prior study, or it is assumed that the average blah, blah, blah. That'll be at the beginning. So,
So I have a question.
uh-huh.
To know if it's the null hypothesis, will it pretty much say at the end of the sentence, all adults or all of something?
Yeah, it'll say all or from a prior study or something. It's like what's known now before you do the study, before you do the
Okay.
sample. Like I said, this is backwards. You would know this before you even took your sample. So they're just putting it at the end of the problem to be confusing. I don't see the point. So that would be at the beginning for me. I would say if the average of all adults, of the oxygen uptake of all adults is 36.7, a physician claims that joggers is more, like I'd put that at the beginning. Okay, so what are we going to put here for our or alternative hypothesis?
Greater than 36.7?
Yep, because that's what he thinks. He thinks it's greater than all average adults. So we're going to check his claim that joggers have a better lungs, basically. Okay, so now we're going to find our critical regions, and we know it's a t-test. So greater than, so it's one tail. What else do we need to know?
The DF is 15 minus 1, so 14.
Okay, so the DF is 14, perfect. And that's from 15 joggers. We do one less for DF. And then we need to know the alpha, which is 0.05. So alpha 0.05, one-tailed 14.
You get 1.761, I think.
Okay, 0.05. Yep, that looks right to me. So we've got alpha 0.05, 14 degrees of freedom, 1.761. Okay, so now we're ready for our test value. We're going to find our T. Which is exactly like finding a Z. It's just you only have the S instead of the sigma. So now we're going to put in the 40.6, right? From the sample. And our mean is 36.7. S is 6. And square root of, oh, I made a mistake. No, I didn't. No, I didn't. I'm good. I thought I switched those by accident. And N is 15.
Do you think they want us, or in the homework, will they say like to round it either to 2 or 3 answers?
Yeah, it'll say.
Okay.
So then 3.9 divided by whatever 6 over square root of 15 is. What are we coming up with?
I got 2.52 if we round it to 2 decimals.
Everybody else got that?
Yeah.
We're good? Okay, good. And again, the book gets stuck on, for some reason, the book does way more rejects than it does not rejects. So 2.52 is up here. But say we had gotten, you know, when we did this, say we had gotten a 1.58, then we would be up here, right? That'd be over in this area. And if we were up in that area, we would not reject. But we got 2.52, which is down here in the rejection region. I should just change some of these problems. And then we've got, we reject or do not reject?
Reject.
Reject. So we do reject because we are in the critical region. So we're rejecting the null hypothesis. And then the conclusion is there blank enough evidence. So is that is or is not?
Is.
Is. You got it. So once we start with the positives, do, in, is. We would only have is not if we had do not in, is not. Okay. I think that might be it for 8.3, if I remember right. Yes. Okay, and then I have to put this up just because I think it's funny. They went to the effort of making a flow chart, which is, I mean, it's valid, but to me, you use a flow chart when you've got a lot more stuff going on than this. But maybe the visual will help some people. So this is their fantastic flow chart. Is sigma known? Yes. Use Z. Is sigma not known? Use T. So that's their big flow chart that they have here. But maybe just seeing it that way might be helpful to some people. It's, you know, just another way of looking at it. And again, we usually only use a t-test if the sample size is fairly small. But you don't really have to worry about that. Just do our methods no matter what they say to the sample size. Okay, so we're ready for 8.4. This is our last section, guys. 8.4 is our last section that we have to cover. Believe it or not. Whoops. Okay, so for the proportion, we're going to do proportions now. And for the proportion, everything is the same that we did for the z-test for the mean. It's just we have to use a different formula to find z. So let's analyze the different parts of this. So what's a p hat versus a p? Do you guys remember from critical values or from critical confidence intervals? Sorry, from the confidence intervals. What's the p hat?
Is it sample proportion?
You got it. Too many p's and s's and stuff. Yeah, it's the sample proportion. Okay, versus the regular p is the population proportion, right? Okay, so that's the population proportion. And then down here we have P and Q again. P we know is the population proportion. How do you find the Q?
You take the, isn't it the P away from 1?
Yep.
Or
So Q is just whatever P is away from 1. So if P is 60%, Q would be 40%. So if P is 0.6, Q is 0.4. And then N, of course, is our sample size. Same as always. So that's our formula. P hat minus P over the square root of PQ over N. So let me write that really quick. So Z equals P hat minus P over, and in this one, the square root's over the whole bottom, not just the N. PQ over N. Okay, so let's see what one will look like.
Wait,
And
what's the N again?
That's just the sample size. Yeah, so however big the sample is. So if it says they did a sample of 20 people, that's your N. Okay. So we've got a researcher that claims that based on the information obtained from the Centers for Disease Control, that 17% of young people 2 to 19 are obese. To test this claim, this is actually backwards. They're making the claim the first one, but we'll just ignore that. She randomly selected 200 people ages 2 through 19 and found that 42 were obese. At alpha equals 0.05, is there enough evidence to reject the claim? Okay, so the null hypothesis, and all your homework problems have it where the claim is the second one. Okay, so the null hypothesis is that remember, this is before you do anything, before you do the study.
Is it 0.17?
Yep. So it's the 17%.
Yeah.
And you can write it either way. Just you're supposed to write P. We're not doing means now, we're doing P. So it should be P. And you can say 17%, or you could say 0.17. They're both appropriate. I think your homework does 0.17 on all of them, but there's nothing wrong with saying 17%.
So you don't do a mean though. It's no longer the mean.
No longer a mu, because we're looking at proportions of the population instead of averages of the population. And so then our null hypothesis is also a P. And what are we trying to check? Greater than, less than, or does it not mention?
I don't think it mentions. Wait.
I don't think so either.
Yeah, so it would be the equal sign with dash.
Enough.
Yep, so the not
Yeah.
equals. It doesn't say anything about it being the researcher thinking it's higher or lower, just wonders if it is. So it's just a not equals. Okay, because I have this up here, I'm gonna do my second step over here so I don't run out of room. So we wanna do our critical region.
I actually have a question.
Uh-huh.
It says on my notes that the H or to 0 or that one right there, that's the claim, but I thought it was the H1 that's the claim.
Well, this one, in this problem, they do have it worded backwards, but I'm not gonna give you any like that. And what's worded backwards here is it says a researcher claims that based on the information, 17% are obese, and they're going to test that claim. That's not the right way to do it. Like, that's not really the way you want to do it. You want to say, from the information up from the CDC, it's 17%. They want to, check if this is valid or something like that in their region. I mean, this is just poor practice, so don't worry about that. You won't have any on your homework that this isn't the claim.
Okay.
They're all going to be that one. Okay, so we've got 2 tails because it's not equals. We're going back to the z-test. We don't have to worry about degrees of freedom. And we have alpha 0.05, 2-tailed. So I'll give you a second. Alpha 0.05. I won't point to it. I'll let you find it yourself. Alpha 0.05, 2-tailed. So are you guys seeing this value right here? This 1.96? Because we're going all the way to the bottom because it's a Z. And 2 tails, 0.05 is the middle column. Everybody good? All righty. I know you're getting probably, and this isn't necessarily a bad thing. If you're like, okay, I get these. That's good. I mean, I'd rather you be bored than frustrated and confused, right? All right, so negative 1.96, 1.96. We good? So if we go less than that, we'll reject. If we go more than that, we'll reject. Okay. So 3, this is what's new from this one, is with this formula is different. So to get our z, we're going to do p hat. What's our p hat?
Would it be the no, wait. It's not the 1.96, is it?
Nope. Where's the 1. Oh no, that's our critical region. Nope, we don't put that in the formula.
0.17?
Is it the 42?
The 0.17 is the p.
Okay.
We're going to use the 42. They actually don't actually give it to you what p hat is. You have to calculate it.
Oh, is it 0.83 or 83%?
Mm-mm.
No.
Remember, p hat is the sample proportion.
Oh, there's a formula. I remember. There's something formula.
And it's not even really, I mean, it's a formula, yes, but it's just understanding. A proportion means like what percentage of the sample. So this is supposed to be the sample proportion, and they told us 42 out of 200. Well, that would be 0.21, because that's like 21 out of 100.
Oh yeah, I see now.
And they're going to do that a lot. A lot of times they aren't going to actually give you the p hat. You'll have to calculate it. All right, so now we're ready for the p and the q. I've gotten better about it, but my biggest mistake I make here is I accidentally will put in the p hat and the q hat, and it's not the same. You're supposed to put in the p and the q. You're supposed to put this in there and then calculate the q from that. So don't put in 0.21 here. We're supposed to put in 0.17. So 0.17 is the p. The q then would be 0.83. Yep.
Yeah.
Yep. So the difference from 1. So 83% and 17% together make 100%.
Mm-hmm.
And then our n is 200. And again, this whole bottom, it's the compute the inside and then do the square root, or do the square root with the parentheses inside. So 0.04 on the top divided by whatever the bottom gets. You should be getting 1.51. Is that what you guys are getting?
I'm still calculating.
Let's see if I can pull my calculator up. I have a calculator here on my screen.
Yeah, I got 1.51.
1.51?
I got it too.
Okay. I have a calculator here on my screen. But if nobody's having problems with it, I won't mess with it. Okay, so 1.51, everybody's okay with that? They're getting it okay? Okay, so
Ooh.
1.51, where's that at? Is it below the 1.96 or the negative 1.96, or above the 1.96, or is it between them?
It's between them.
Yep, it's only like right here, right? 1.51 is like up here, but not above 1.96. I mean, this is like 1.5. 1.96 is almost 2. So 1.51, $1.51 is less than $1.96. So it's down here below that. So we are going to
Not reject it.
Okay. So we're going to not reject because we are not in the critical region, right? And so there is not enough evidence. So this researcher took that null hypothesis of 17% of young people are obese, took that to trial, tested it, and did not have enough evidence to prove that it was wrong. So we're saying we don't have enough evidence to show that it's not 17%. Doesn't mean it actually is 17%. It just means this sample, this study did not find enough evidence to show that it's not. So we're just going to have to go with the 17%. So in this case, the null hypothesis was not guilty. Okay? It was not found guilty. We did not reject. So the claim is wrong. There is not enough evidence to support the claim that it's not 17%, because we did not have enough evidence to convict that null hypothesis. Okay, and that's it. That's what we're going to have for the proportions. So let's do, yeah, we only have one more example. So let's do one more example, and we'll call it a little bit shorter day than what we've had in the last couple times. I thought for sure we'd be spending about an hour and a half, but we've been spending closer to 2 hours. That's okay. It's nice to have the, and it's nice, I know some of you guys that have been here are even still watching the recording, so that's kind of nice. That you can go back and look at it. Okay. Our very last new example. Well, I mean, I'm sure we'll have some new examples when we review, but all right. So it says a Gallup crime survey stated that 23% of gun owners are women. So if you take all the women that are all the people that own guns, they think 23% of them are women. A researcher believes that in the area where he lives, the percentage is less than 23%. So not necessarily that this is wrong, but he wants to know, is his region different than that? Okay. He randomly selects a sample of 100 gun owners from his area, hopefully, and finds that 11% of the gun owners are women. At alpha equal 0.01 is the percentage in his area less than 23%. Now, you can get, I mean, this is pretty far off. I'm pretty certain that we're going to reject on this, but we still should run the hypothesis test. And we know it's it's proportion, so we know we're doing a z-test. What's our null hypothesis? Where are we starting at?
0.23.
Yep, and that's a p, right?
Yes, ma'am.
So it should be 0.23. One of the bad things about the homework is on the homework, every time they just give you this p, and so you kind of forget that you've changed values here. But we've been doing mu's, and now we're doing p's. Okay, less than, greater than, not equal.
Less than.
10.
Okay, so less than, so that's our here. And again, this is always going to be your claim in your homework. So our claim is that in his area, it's less than 23%. Not that that's wrong for the entire country, but that it's different in his area. Okay, so now we want to find our critical regions. It's less than, so it's only down here. One tail, alpha's 0.01. We're doing a z-test. One tail. What are you guys getting?
Negative 2.33.
Yep. Good, and you remembered the negative, so that's good. So 2.326 is what you get off the chart. We'll just round that to 233. But you are correct, we've got to put negative. And so if our test value comes out lower than negative 2.33, we'll reject. Okay. So Z equals P hat minus P over square root of PQ over N. And of course, you do not have to have that memorized. They have it on the formula sheet. So if you go up here to chapter 8, you'll see there's the Z-test where you have the sigma, the T-test where you only have the S, and it even tells you degrees of freedom is N-1. And then Z-test is right here. So all the formulas are there. You don't have to have memorized, just have to know which ones to use. Okay, so what's our P hat?
Would that be the 0.11? Because it says
Yep.
out of sample of 100, he finds 11%, right?
Yep. So in this one, they were nice enough to say 11%. It was a sample of 100, so that means he found 11 of them. So if he said I finds 11 of them are women, it'd be 11 out of 100, which is still 0.11. So they could give it to you either way. Okay, and then what's our P?
0.23.
Yep, same one that we had up here. We just said it right here, P is 0.23. Okay, and then our P and Q.
Uh, 0.23 and 0.67. Oh wait, not 67. 77.
Perfect. Okay. And then N is 100. And like I said, can you see how my mistake that I used to make all the time would mess this up? Because if I put in P hat here, I'd have 11 and 89 instead of 23 and 77, and it throws it all off. So do not be me. Make sure you use this P and then find the Q from that. Don't use the P hat. And if everything is going well, you should get negative 2.85. Is that what you guys are getting? So far, so good? Okay. What do you guys think? Reject or not reject?
Reject.
Not reject. Wait, reject, my bad.
Reject, because we're down here, right?
Yes, ma'am.
So negative 2.85 is going to be down here below negative 2.33. And so we are going to reject the null hypothesis. So we've convicted the null hypothesis. We said you're not right for our area because we're in the critical region. And so there is enough evidence to support his claim that his area is different. And not actually different, that his area is less. So since he started with less, he can actually say less. There is enough evidence to support his claim that in his area, it's less than 23% of women that own guns. So that's it. What do you guys think? Anybody have any questions before we call it a day? Remember, we'll have next week to review, and then we'll have for the 7-8 test, then we'll have the following week to review for the final. And you guys can take the final. I mean, you can honestly take the final early. You can take the 7-8 test anytime I get it up. Like I said, I'm struggling with how to do that well. So, and I'll try to let you know what I end up doing a little bit more specifically. I want it to be as similar to what it would be if you were doing a handwritten test as I can, while being in the constraints of the D2L quiz options. So anyway, anybody have any questions? Okay, great. Everybody have a fantastic day. I hope people will be here. Please do try to come next week for the review. I know it's easy to go, it's just review. But, you know, I really try to give you some hints and some ideas and focus on what you need for the test. So I think the 7-8 test is a lot more focused than either of the other two tests. It's just confidence intervals and hypothesis testing. That's it. That's all that's on the next test. It's and so it's very limited. especially in comparison to like when we did probability and stuff. So, all right, I'll quit rambling. You guys have a great day. I will
Okay,
see
you
you next
too.
week.
You too. Happy Mother's Day to all the mommy.
Thank you. Yeah, happy Mother's Day. Good point.
Yes.
Take care, everybody. And
Okay.
if you are not a mommy and you have a mommy, make sure you
Your mommy.
say something, do something nice for her. All
We'll
right.
be doing that. Okay.
All
Bye-bye.
right. Bye-bye.